The main idea in this section is distinguishing between equilibrium and a system that is momentarily at rest. So equilibrium means that the net force F net is equal to 0, 0, 0, and therefore we have a constant momentum and velocity. Equilibrium doesn't necessarily mean stationary, it just means constant velocity, net force of 0. But it is possible for moving systems to go through zero velocity, and this does seem to cause some confusion because people are associating equilibrium with zero velocity, and that isn't the case. So we take a look at a spring moving up and down with a mass on the end, and at this point right here, at the very bottom of the bounce, the momentum is 0, and the velocity is also 0 at that point. But that does not mean that the force is 0 at this point. In fact, with the spring, since the spring is stretched its farthest, the force is actually the largest on it at this moment. If you look at the spring, and if this is, say, the midpoint of the motion, then the velocity is the largest at this point, but briefly, the net force at this point is 0, 0, 0. This is the equilibrium point. This is where the spring would come to rest if it was left to its own devices. And then the spring will go up, and when it reaches the limit of its motion, it will again briefly go through V equals 0, and again at that point the net force is the largest, and then the cycle will continue. So the interesting thing about a spring system is that when the net force is 0, your velocity is largest, and when the velocity is 0, the net force is largest. Now, another example of a system that is momentarily at rest would be somebody swinging back and forth on a vine. So at this point right here, at the highest point of the swing, they go through V equals 0, but the force that's pulling them back towards the center is largest. And just to take a look at the forces on the, I guess it's Tarzan at this point. So we have F grav on Tarzan by Earth, and we have F tension on Tarzan by Vine. And if we go ahead and add these two forces together, what we're going to find is, so here's the tension force, here's the gravity force, here is the F net, this guy right here. So the net force on Tarzan at this point is back and down. And so this is another example of when the velocity is 0, the net force is largest. When we get down to the bottom here, the net force is not 0 at this point, but the component of force that is speeding up or slowing Tarzan down is 0 at this point. A third example of a system momentarily at rest would be a ball rolling up a hill. Now we need to be careful because at the force on the ball doesn't actually change as it rolls up. So at this highest point, the net force is the same as it was at this point, but again it does go through V equals 0. But once again, just because V equals 0 doesn't mean that the net force on the system is 0 either.